In this video, I'm going to show you a very interesting network data set made available by Indiana University and some of the interesting analysis that you can do on that kind of a network. So I'm going to show you some very basic things that you can do. I'm going to go here and there is this observatory on social media, which is by Indiana University. Let me just click on this and you can go and click on tools. It gives you a lot of tools through which you can collect. You have some of the data from Twitter. We are not doing it in real time. Previously, it was sort of real time, but the data is limited in the sense that I think after May 2023. So all the data that you'll find here is before all the Twitter restrictions were there. So it's before 2023. Let me first show you this, which is trends. So you can actually pass in any hashtag over here and then see how much it was being talked about on Twitter. So I'm going to take a hashtag, let's say layoff. And there were a lot of layoffs in companies from in I think January 2022 particularly. So let me give it a timeline from January to January 30, let's say. Okay, so as it shows you in this particular period, the number of people discussing about layoff have decreased. So let's see where it was being talked the most. So let's say January 2021. And the graph becomes very squished because these two timelines are like an year apart. You can actually click on this and it will show you only one. And then you can click on this, it will show you the other one. So in 2021, it is roughly this. This is 1, 2, 3, 4, 5, and then 71%. And you see it here, so it's less. Right, so let's stick to 2021. So in January 2021, it was being talked about a lot more than what it was in 2022. So we'll stick to January 2021 and then try to analyze. I'm going to go back to the tools, and what are the more interesting tools are these networks that you can generate and see how things are getting retweeted. And let me again say layoff. And I'm interested in seeing what people were talking about layoffs in, let's say, uh, going back to, okay, it doesn't have data before May 2021. That is sad. So it is from May 2021 to the latest data is, let me check, May 2023. So it's a 2 year data. Let's stick to 2023. So I'm going to take January 2023. What were people talking about layoff that time? And then again, January 2023. Now, the thing is, if you look at the data over here, it doesn't give you the exact content from Twitter. What it gives you are some kinds of networks. So one of the interesting kinds of networks is actually the co-occurrence network. So the first one here is a retweet network. Now I'm not going directly with that because first you can actually give a comma separated list here. It needn't be just one hashtag. So I first want to see which hashtags were more commonly tagged alongside layoff, and then use the most prominent of them together. I'm first trying to see which hashtags co-occurred with this layoff hashtag. So I'm going to generate a co-occurrence network from here. And then this tool over here provides you some basic visualization of this network. And if all you want to do is just visualize it, then I think you can just directly export this image from here. So as you hover over it, you can see which hashtags were being talked about together. You can go to controls and you can control the node size. And as you do this, you also see the major hashtags, right, which co-occurred with layoff. And you can just play around with this, and I think you can rotate this network to see what it looks like and see what is happening over here. But I think to see what exactly were the major hashtags, we need to do a little bit more detailed analysis of this network. You cannot do that directly here. So a good idea is to export this network, and then you can use iGraph to analyze it further. So instead of downloading a CSV file this time, because if you download a CSV file, you'll have to follow the same path. Import it as a pandas data frame and then convert it. Rather, I'm going to use this format GML, which is very popular for graph kind of data sets. I'm going to download it, and you can just import this graph with simply just one function in iGraph. So I have this network here, and I'll create a new notebook, and I'm going to name this one as layoff. And I'll get that file here. So I'll have to wait for some time till it connects. Yeah, it connected. So I'm going to downloads and getting that GML file over here. It will take some time to load it. So meanwhile, I'll install the required libraries. So I need iGraph and this plotting library. Those are the two major libraries that I'll need. And then I'm going to import iGraph as IG, and from iGraph import graph so that I can create graphs. And I am going to rename this file as COOC, which is nothing but co-occurrence. So it's a file called co-occurrence.gml. Now I can directly import this file with just a single function, graph.read underscore gml COOC.gml. Yeah. So I got this graph, and you can print this graph to see what it is about. And it shows you a lot of information. Actually, it shows you all the available edges in the graph. I don't need this much of information. So I need some basic information. So which you can see here, it's a directed graph, it's a weighted graph, it has 1654 nodes, around 13,000 edges. Every vertex has an ID, label, tweet ID, type, weight. I'm sorry. So your vertices have ID and label, and your edges have tweet ID. So you can actually fetch some content of tweets from here. So if you have a developer account of Twitter API, so using this tweet ID, you can actually extract the content of that tweet, and you have type and weight of these edges. If you only want to see exactly what is required, instead you can call a function which is ig dot summary of g, and it will show you only the most important things and not actually print out all the edges of this graph. Now, next comes is we can also visualize this graph. So let me say ig dot plot g, and it might take some time because it's a big graph, and it also might not be visually very appealing. So this is how this graph looks like, very big, and a lot of labels are sort of overwritten here. So what we can do is maybe for the meantime, I wouldn't want to see any labels, and then we can control the size of the box. Let it be bigger. I don't think that's a problem. And we can control vertex size, let's say 10. You can control edge width, can keep it as zero point 0.5. And let's see how much difference is there this time. So you have to actually play around with these parameters to obtain the best possible visualization. This is what we get now. Still, it doesn't look much better. Our arrow sizes are very big. We can also control those with edge arrow size, and let me make it very small, say 0.2. So this is how the graph looks like. Still it doesn't look very nice. So one reason why it's not looking that nice is there are a lot of vertices which are sort of overlapping. So in these cases, using a particular layout helps. So let me try a mm, very popular layout. It's called Fisherman Ringgold. So the idea of these layouts is they run some kind of algorithms on this graph to find out the best possible positions for the nodes. Let's say layout equals to FR, which is the short form for determine green gold. And hopefully, uh, okay, still, still it doesn't look a lot good because there are so many, as you can see, right, disconnected components. So this big one cluster isn't visible very nicely. We can try by reducing vertex size and then see if we can obtain a better visualization. Still not very good, but much better than before. Now, what we would typically want in these graphs is, you see, we are not very concerned about these small nodes hanging out here and there. So we would like to ignore all of these, and we are more concerned about this one big giant chunk which is connected, which is also called the giant component. So we are going to extract this and visualize our network only for this chunk over here. So we can use an algorithm called a function called g dot components. So it will give you all the components of the graph, and I'm going to keep them weakly connected for the, and let me get that in a list C and see what happens. So if I print C, it's again an object, so converting it into a list, right? And this gives you all the available components. As you can see, most of them. So you see here is a list of just two nodes, 0 and 1, which are not connected to the remaining nodes. And then you will see a big list, and then there will be some smaller list. So what we can actually do is, it's a list of list. So just want to look at their sizes. So for each in list C, let's look at what is the length of each. So instead of printing the list, let's look at their length, and you can see that these are the length. So there is this one big component having 1616 hashtags, and rest of them are fairly small. So what we want is we want only this one and not the remaining. So what we can do is I'm making one more list VID, and I'm extracting the indices of only those vertices which are there in this component. So for each in list C, instead of printing it, I'll do it if the length of each is greater than 1000, which is true only for this one component over here, then I'll iterate over each vertex in this component. So let me say for u in each vid dot append u. Right? And now you can look at what is vid. It will have all those vertices, all those 1616 vertices. So if you look at the length of vid, it is 1616. Now I want to create a subgraph of the original graph only on these vertex ids. I'm going to create a subgraph. Let's call it gc, standing for giant component. It is g dot subgraph. Give me a subgraph only on these vertices which are in vid. So rest of the nodes will not come here. So you'll only get a graph only for these vertices here, which are in the giant component. And let's again plot it. This time I'm going to plot GC and not G. Let's see if there are some improvements. Yeah. So I hope it is much better than before now. Right? So you can see, so this area is very dense. It's really difficult to see here, but again, edges can be nicely seen. One thing that you can make it make it slightly more visually appealing is to make these edges a little bit curved instead of all of them being exactly straight. So that you can do when, let's say, you are reporting the visualization in a paper or a project. If you make these edges curved, the graph just appears a little bit better. Right. Now, this is the graph that you get, and it's really huge, and we want to figure out. So all of these nodes, they are the hashtags which have co-occurred with the layoff hashtag, and we want the most important of these hashtags. Now, one thing about this network is that it's a directed network. So what we can do is we can convert it into an undirected one. So directedness, you can understand the meaning of that directedness from is here somewhere they would have described. Yeah. So your nodes are the hashtags that co-occur with the queried hashtag. Edges represent tweets in which two hashtags co-occurred with the queried hashtags. Right. So whenever you see two more hashtags with the layoff hashtags, they come over there. So I think that the direction here simply tells that which hashtag came before or which one came later. Right. So one thing you can do is you might want to ignore directions. I'm going to convert this graph to undirected, and so there are multiple ways in which you can convert a graph to undirected. So one is simply you ignore directions. So if you ignore directions, all of these directions, they will just vanish and the graph will roughly remain the same. Another idea that you can use is you only keep those edges which are bidirectional. So if there are two hashtags which both point to each other, only then you keep them. So let's try the second way first. So I'm going to create an undirected version of this graph. Let me call it UG, and it's going to be your giant component. dot so there's a function called as undirected. I want to convert it into an undirected graph, and I'm going to say mutual. Mutual means you only keep the mutual ties and remove all of the remaining things, and you will see what you have to be very careful about it. It can make a huge difference to your original graph. So I'm going to plot UG now and show you what just happened. You see, the entire graph sort of fell apart, other than these few bunch of nodes here, which are again really tightly knit with each other. So we can again repeat the same process that we did before. We don't want all of these scattered components. We only want this one dense portion over here, because they represent the most relevant part of our network. So I'm going to apply the same idea over here on actually UG. So this was the place where we figured out the components. And since it's the undirected graph, I don't need the part V here. So you figure out the components of UG. Once done with that, you append the VIDs. And this time, why does it say it has 0? So C is G dot components. Yeah. So we need to analyze the size of these components. Let me keep it 10 and see how many do we get. Right. So 221. So there are 221 nodes in one component. We are only going to be worried about them. And then we are going to create, let's say, a graph G on this UG dot subgraph and only on VIDs. Why does it show a line under UG? It says UG is not defined, but yeah, UG is defined. I guess it's not a problem. So yeah, it ran, and now let us plot G, and you can see this one component over here. Right? And again, as you can see, it has this dense part over here, which seems to be the most relevant. So most of this dense part, if you will see, they are the nodes having like very, very high degrees. So we need to figure out which are these nodes. So to do that, one thing is now maybe you can show the labels for all of these nodes. So let me remove this. So show us the labels. So again, it is overlapping a whole lot. So that's the problem, that you have to write a code and you cannot see everything in like this visualization. But yeah, you can see some related tweets, related hashtags here, like Amazon layoffs, Bangalore, Oracle, and basically the names of some companies, etc. But again, what we want is, let's say, the highest degree nodes from here. So let's see which are those nodes. So let's look at G dot degree and let's see what all degrees are available. So you see, most of the nodes, they have degrees of less than 20, and there are these 4 nodes which are having very high degrees, right? So they have been retweeted a lot with the hashtag layoffs back and forth. So let us see which are these vertices. So all the vertices which have a degree of more than 21, we want them. So what we can do is, first of all, I'm going to set a new attribute for each vertex, which is their degree, which is again nothing but G dot degree. So this time, instead of extracting the value of an attribute, I am actually creating one, and you get this G dot degree. And now I want the highest degree nodes in a list L. So what I'll do is, for each in G dot VS, if each degree is greater than is greater than 20, I'm going to append L dot append. So you can actually append the label of each. I want to see what exactly is the label of this vertex. And once it is done, you can look at the value of L, right? So these are actually the most co-occurring tweets with layoffs. So one is job cuts, layoffs, RIFs, and the layoff. I'm going to take these, and these makes are relevant hashtags. I'm going to put them here. And my original hashtag was hash layoff. And then we want this job cuts, layoffs, RIFS, and the hash layoff over again. So we were talking about January. So let's come back to January 1st to January 30. And this time we are going to take a look at retweet network. So this retweet network now gives you an idea of which users were talking about it and which Twitter users were getting the most retweeted, talking about all of these. And as you can see, it's a much sparse network as compared to the hashtag network. Right? So you can actually click over here to see who were the users. Right? And you can actually click here and you can click here and it will automatically open up the Twitter account of that particular person. And you can also manually do it. So again, it's very difficult to see which person got retweeted the most from here, from this network. So again, a good idea is you export this network as a GML file and then open it again there. So I'll do just one analysis here. So there's a lot of scope here that you can work on. So yeah, I've downloaded this and let me get this network here. And I'm going to rename it as retweet.gml. And let's get that now as a new file. Graph.readgml retweet.gml. And let's look at ig.summary of G. Now, this is also going to be a directed graph. So again, you can do a whole lot of analysis here. You can identify communities, etc. So I'm going to show you one thing here, and that one thing is which users are the most retweeted ones. Your vertices again have some kind of labels. Let us see what these labels are. It's a small l. So you can see these labels are nothing but the Twitter users. Now what we are interested in is which user got retweeted the most related to job cuts. So uh, what we can do is there's a function called g.inDegree. So inDegree tells you how many times a person was retweeted, and there's like a large number of nodes. Hmm. Yeah. So let me look at this set of this. So what are the available in degrees instead of looking at the list? And then you can see that this is what happens. Most of the people got retweeted 17 times. And then there are some of them. These three people got retweeted a lot more times. So let's again be concerned about these three people. And you can use the same approach that we used here. So I'm just copy pasting it so that we can do it quickly and identify who are these people. So this is G and what we want is in degree this time. And then you iterate over all the vertices of G, and if its degree is 20, then you append its label and you can look at the L. What is it? I find these three people. Now I don't know what exactly is the reason that they were retweeted the most. So maybe you can just go to Twitter and can look at what really happened. So I think yeah. So this person seems to be like a full stack engineer. Okay. So I'm like quite sure he should be like a popular person or something like that. So like even if you search for him on Google, maybe you get a lot of information. So that's one person. So you can see that these are the like legitimate Twitter profiles, right? And then another is this Praveen Time. I don't know this W_E_5. We can also check for that. I don't know this. Okay, so this account has been removed, and then so again, one thing that you might want to keep in mind is this is not like all the tweets. So these because Twitter data set is very big, so these are some randomly sampled tweets. So this is yet another account. So there can be other better ways to do at it. We have done a very basic kind of analysis over here, just to give you an idea of what kind of data is out there and what you can do with it.